All right, class. So we should have a pretty good understanding at this point of how this board is working, how display board is working, valid move is working, and we're moving on to checkWin. Moving on to checkWin, which is so far we kind of had this idea. Well, if I had a board that looked like this with a winning first row solution, this check right here would work for it, you know, and I think it's kind of logical just to try to scale that idea. So I come in here and say, well, what about the second row? Kind of try to figure out the second row on my own. And there's a winner in the second row. Just to kind of validate that idea, let's go ahead and do this. Now notice that when I'm printing right now, so there's a winner in the second row, but the return is none. Since I'm printing out, there's no return actually, because I only get a return for a row one sort of winner. So now let's kind of attack this and say, well, really, I'm going to copy and paste this idea basically with maybe one small change. Instead of saying the first row, let me say the second row. And that's first index, you know, especially in this two-dimensional array structure, that first index is the row. So, okay, well, yeah, that should check the second row, right? And sure enough, I get a 3. I get a 3, which is, well, I'm supposed to get if O wins. Uh-oh. Uh-oh. Why am I getting a 3? Oh, I know, because the code that I copied and pasted, which is why it's very dangerous to copy and paste, the code that I kept copy and pasted said, let me check the value in this spot and see what it is. Well, that's a no. I want to check the value in one of these three spots, any one of these three spots, because it must be the same. So I could just say, okay, give me that row again, and second row. So now I do get 2 because it's X there, right? And so if I wanted to change it to O's, I should see that it works. And so you say, okay, well, let me come in here and say, I know how to handle that third row thing. I think I have a pretty good idea to handle that third row thing. And third row is going to look like this. I got to change basically all these first indexes to indicate the third row. And I could certainly check to see if that works. Kind of want to make sure that this isn't a win, you know. And say, let's make this a win. And sure enough, I'm getting 2. Okay, great. So that works. So you may say to yourself, and by the way, you should be saying to yourself, anytime you're copying and pasting kind of chunks of code, well, you really should have an opportunity for a for loop here, right? And so let's think about this. You know, these 3 sort of blocks of code are all identical. You know, the second index is you know, exactly the same every time. The only thing that's changing is this first index, right? And in this first iteration, it's a 0. In the second iteration, it's a 1. In the third iteration, it's a 2. So, okay, well, let's see. How do I do something which gives me the value 0, 1, 2 in a looping structure? 0, 1, 2 in a looping structure. Well, that sounds like for I in range 3 would do that idea. And I could kind of take this code, right, make it the body of my for loop, and then instead of having 0, that I could put I there. I put a 1 there. And sure enough, I'm getting 2. I'm getting 2, and I should get 2 because x1 something. Now, really honest, you probably test all the rows, make sure all the rows work for x's and o's, or at least do a few more checks, I think. But I feel pretty good about this logic. Now, the only thing I don't feel particularly great about is the variable. And so even though I is very classically used with the range function, I would feel better to label this row, because it really is referring to the fact that we're going to iterate through the different rows in the board. And so when I say row index 1, row index 2, I mean, yeah, I mean like in the first row, let me check the left spot, the middle spot, the right spot, and et cetera, et cetera. So I kind of like that idea. Now, there is a way that I could just do this all in one loop. There is a way I could do that, but especially because I changed the variable name, I want to do it. I'm just going to do another for loop here and just call this column, right? And hopefully this isn't too much of a stretch, although it may seem like magic a little bit. Maybe I should actually explicitly do one of them. But instead of changing the column, because essentially, okay, let's look at this. Let's look at this first kind of solution here, right? First solution. We're going to keep row the same in the check here. Row the same, meaning that I'm saying, okay, the first time through row is 0. That's the first row. Let me check what's in the first column of the first row, the second column of the first row, and the third column of the first row, and see if they're the same. Well, so I'm keeping row the same and checking different columns, right? So what I want to do here is keep the columns the same and check different rows. So say like 0 column, 1 column, 2 columns. So let me check the different rows and keep the column the same. So when column is 0, you're checking this sort of structure. And then what I want to do, I want to check, well, it doesn't matter if it's 0, 1, or whatever, but it's 0 column, one of those deals. So let's try to create that winner kind of a deal. So how like I say 0, or not 0, but 0. Now, tricker is, do I have any other winning deals? And we'll see it when we run display board. So let's take a look at what we did. Did we create that sort of winning structure in the first column? We did. Do we have any other win scenarios? No. And so O is a winner, and so we should have a 3, and sure enough we do. So maybe we try getting X to be the winner, and therefore let's make sure O is not a winner, so we have no conflict there. And let's run this, and sure enough X over there gives us 2. So yeah, I like it. I'm pretty comfortable with the logic. That's not too bad. Now, someone asked about this earlier. So, well, how does Python know the difference between row and column? It doesn't. I mean, it's just that's a variable. It just contains a value. And since we're using the same value, since we're using like 0, 1, and 2, do I really need 2 different for loops? Because this all happens inside one for loop. It absolutely could. I'm just liking the different variable names and like kind of highlighting maybe why we're able to do it like this. Now the other 2 things. I know top left corner is 0, 1. I know the middle is 1, 1. And I know the bottom is 2, 0. Right? And then, so that's me checking a diagonal here. And I know this should be 1, 1, right? Okay, so that's a diagonal starting top left going through. Let's see. By the way, not a bad idea to comment this code and just go like, not a bad idea to do that stuff just so you know what you've done or what you think you've done, And so this one's going to be 0, 2, starting top right and going, where? 0, what am I doing? This is way off. This should be 0, 0. This should be 2, 2. I don't even know what I was thinking of. Okay, let's think about this again. Let's think about this again. 0, 0, top left. 1, 1, middle. 2, 2, bottom right. Like it a lot. I like this. Top right, middle, bottom left. And again, I can always check 1, 1 because that's middle is going to be part of diagonal solutions. So looking at this, again, if I only had one loop structure, I could just, say I was up here in the row. I could just kind of put like row. No, I couldn't do that actually. Anyways, yeah, so I've checked the two diagonals, and let's see, let's try to create ourselves a diagonal solution that's a winner. See if it works, XX, and how about putting XX here? I think I've given myself other ways to win, though, so let me put like 6 here. Let's see what this looks like when we display it. Unmatch. Wait a second. I don't like that. Interesting. So it's actually, I left up right there, I don't know. But it's actually treating like it's a tuple, which is very similar. So yeah, so the only winner I have here is the diagonal win. I have a diagonal winner. And it returns 2 for X. And I feel pretty good about the logic. Really probably should check more, but I'm going to not. So I'm just going to move on. But you should maybe check the other diagonal, make sure it works for O's. So what I have here is a way to check for wins. So I've checked the 3 row ways to win, the 3 column ways to win, both diagonal ways to win. Again, this could have been condensed, arguably, but you know, whatever. It's working. It's sort of functional, right? So let's move on a little bit here, and let's say, how do I determine if it's a tie? How do I determine it's a tie? Wow. Basically, if every spot on the board has been used, it's a tie, right? And you say, well, how do you know there's not a winner? Well, if I get to the point where the cursor's blinking, I know there's not a winner. I know it. I know it. So how do I know that every spot in the board has been used? I don't know. I mean, there's a couple ways you could do this. Couple ways. Oh, I saw kind of a cool implementation. Where someone said nums equals 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a little shortcut. Instead of like having to check each value each time, you could just go, okay, well, let me iterate through this board. And check to see if any of these things happens to be a number, one of the numbers that's starts out on the board. So if board row column is in nums, right? What does that mean if board row column is in nums? What does that mean? It means that the game is not over, actually, doesn't it? So I don't know if this is actually the way I meant to go about doing this, but let's just kind of sanity check ourselves here and say, okay, I'm iterate through the board, right? I'm looking to see if any one of the objects in board is still a num. So like, is it because when we first start out, we got 1, 2, 3, 4, 5, 6, 7, 8, 9 there. We start putting values in the spots or letters in the spots, and so as long as there's still numbers left, I want to argue that I should just return 0. The game is not over, right? So now it's a situation where I'm getting to this blinking cursor and saying, well, if I get here, it means there must be no numbers left in the board. It means we must not have had a winner. How do I know we haven't had a winner? Because we already checked to see if we had a winner, and therefore the game should still be played. So I like that. And let's see if these ideas kind of play themselves out. I'm gonna make 5 and L. I'm gonna make 6 and L. Oh, that's right. So let's see what we got here. We got not a winner, right? Not a winner. Every spot is taken, and we return 1. Is that what we want? Is that what we want? If the game is a tie, we want to return 1, and there we go. We got it. What if there's still a couple spots left? Oh, I'm trying to change that. So what if there's still a couple spots left? Like, for example, this is a 5. And this is let's take a look at our board. So we don't have a winner. We don't have a winner. All right. And there's still a couple spots left. So we're going to return 0. Why that happened? It happened because, as we were going through the array, we found a number, one of these numbers. So I like it. I like that logic. I like the logic a lot. So hopefully that's helpful. And now, if you have a working checkWin, a working display board, a working valid move function, like see if you can kind of put these things together and get the code to work. Right? It's kind of a fun challenge, I think.